And here's our first example. The following table gives information on average saturated fat in grams consumed per day and cholesterol level in milligrams per centiliters. Of 10 men taken from a simple random sample. So we have the fat consumption in grams for each and the cholesterol level for each. They want alpha to be 0.01 significant to determine if there is a linear correlation between saturated fat consumption and cholesterol level. So the null hypothesis will say, well, there is no relation. The alternative will say there is. It's different. It's above or below. So they are related. And it seems you are determined if there is a linear correlation. This is what you're testing. Alright, and how does this work? Well, a couple of things. One, we need the test statistics. So we need to get R. Now to get R, this is how we're going to do it. We're going to go to our calculator and we're going to use stat test linear regression t-test. So we're going to go for first we're going to go to stat and we're going to input the data that we have. So we have 55, 68, 50, 34, 43, 58, 77, 36, 60, and 39. That should be the 10th. Let me double check. 55, 68, 50, 34, 43, 58. Yep, they match. And then I'm going to go to the second column and I'm going to input, so just move the arrow to the right, 180, and they have to match, they have to pair, 195, 165, oops, 170, 204, 235, 150, 190, and 185. And now that I have them in, I will quit. And now I'm going to go to stat and test. And it's on the bottom. You could move down. I'm going to show you two ways of getting there. You could move down until you see the linear regression test right there. That's one way. I'll show you another way of doing it on the other problem. L1 correct, L2 correct, frequency equal and not equal, that's right. And calculate. And we're going to copy this information in. And I'm going to show you where everything is. There it is. That's all the data that we need. That's actually more than what we need. So I'm going to take this and put it on the side. And notice what we have. Oh, it didn't show. Okay, this is not big enough. Let me see if I enlarge it a bit. Still not showing, just making that bigger, which is annoying. So if you have a whole page, if you scroll down, there's R right there. You want R. So this is the part that you want to get, not this. So you're going to have to scroll down a bit because the other information is not needed. This is the stuff that you need right here. So here we are. So R, so you scroll down a bit and you get R right there. So when I do my test statistics, T naught is R divided by the square root of R squared divided by degrees of freedom. R is 0.01. 0.9079 square root. R squared is right there. 0. Oh, I'm sorry, that was the square root of 1 minus R squared over degrees of freedom. So this is 1 minus R squared 0.82431 divided. Remember, degrees of freedom were n minus 2, since n is 10, n minus 2 is 8. I throw this in my calculator. And if I go for 0.9079 divided by the square root of parentheses 1 minus 0.82431 and divide that by 8, I'll get an answer of 6.13. So this is the importance of that. I'm going to go in, always double-sided, p-value 2 times the probability that t is less than negative 6.13. I'm going to plug all of that in my calculator and get the probability. Remember, they want alpha to be 1%, and let's do that. If I go for my distribution, t-distribution, CDF, and I want from negative, that's right, to negative 6.13. Degrees of freedom, we said, were 8. And there's my answer. Oh, and 2 times. Okay, you can barely see that. Let me go ahead and get that going. So I get the answer to be 0.00028, which is 0.028%. Well, obviously, that's almost never happening. Reject null hypothesis. Now, the critical value is a slightly different game. Oh, you know what? I didn't copy the other piece. That's what I should have copied as well. Let me get that in. So if you look at the notes, you know how we did this. There it is. So for the test statistics, I'm looking at the formula sheet that you guys have. And if you look at the second page of that formula sheet, so the formula sheet looks like this. The second page has this table in it. We want n equal 10. So there are only 2 values for n equal 10, if you notice. There's alpha equals 0.05. Oops, that's not what I wanted. You'll notice there are 2 values. There's an alpha equal 5% and 1%. So those are the only 2 values you could test on. Since they did say use alpha equal 0.01, we're going to say the cutoff is 0.765 and negative 0.765. Remember, this is backwards. This is the rejection region. This is strong positive correlation. This is strong negative correlation. And if you look at what R is 0.9. So isn't that to the right? So that means they are correlated. And remember, correlated means you support the alternative hypothesis. You could also do, if you really want, a t-distribution, since it is a t. This is alpha over 2. This is alpha over 2, which is 0.1 divided by 2. Degrees of freedom will be 8. You could use, if you want, an inverse t-distribution and figure out the rejection region like we did before. And you're looking for an area of 0.1 divided by 2. Not 0.1. 0.01. Right? Degrees of freedom are 8 in this case. And that tells me that this is 3.36, negative 3.36, and I notice the test statistics, which is 6 point, falls in the rejection region, so we reject the null hypothesis. So here, this rejection, well, I shouldn't have said rejection, I should have said no correlation, correlation, correlation. So we reject the null hypothesis, meaning there's a relation. A relation means not the null hypothesis. So what do we say? We say there is sufficient sample evidence to support that there is a linear relationship between fat consumption in grams and cholesterol level in milligrams. Okay, the last example we have, the following table gives the total 2004 payroll on the opening day of the season, rounded to the nearest millions in dollars, and the percent of games won in 2004 by the National League team. Okay. And these are the teams, payroll in millions and the wins, and there are 16 of them. Use alpha equal 0.05. Significance not to determine if there is a correlation between the payroll and the percent of game wins. They're thinking, if you pay them more, would they win more? And how many teams do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 16 teams. N equals 16, so degrees of freedom will be 14. Now let me find the correlation between those. Let me get my calculator and input all of these. So we're going to go for stat, edit, and we're going to go to the first table and input all of these numbers. 70, 90, 91, 47, 65, 42, 75, remember these are millions, 93, that should be the 8th, 28 million, 41 million, 97, 93, 32, 83, 55, and 82. And we're going to move to the other, go all the way up, and we're going to start with, what does that say, L7? I want to go to L1. Here we go. L1, that is 31.5, 59.3% wins, 54.9, 46.9, 42 even, 51.2, 56.8, 57.4, that should be the 8, that's right, 41.6, 41.4, 43.8, 53.1, 44.7, 64.8, 53.7, and the 16th 56.2. So that's my data. I already input that in. Now I quit. Now, so let's run the numbers and see how that works. We're gonna quit and we're gonna go to stat. We're gonna test. And remember, I showed you, I was gonna show you another way. If you go backwards, up, not down, you would see the linear regression right there. Faster. Linear regression. Correct, correct, correct. And calculate. Remember, we're going to scroll down just a bit. There it is. That's what we need. So I'm going to scroll down and copy this data. Here we are. And shrink that a bit. And here we are. So we got it. Now, of course, the null hypothesis. So we're saying, check if there's a correlation between those. The null hypothesis will simply be, there is no correlation. Those are not related. And the alternative would be, of course, that there is a correlation. Those are related. Okay, and determine if there's a correlation between those or not. Okay, so what do we need? The test statistics is always a t. T naught is, if you remember, that was r divided by the square root of 1 minus r squared over degrees of freedom. R is 0.482 divided by the square root of 1 minus r squared is 0.2325 all over 14. I plug this in my calculator. I'll take 0.482 divided by the square root of parentheses 1 minus 0.2325 squared. No. Divided by 14. And there it is. I got it to be 2.06. Very good. Okay, now let's do the p-value. The p-value is going to be two-sided. Twice the probability that t is less than negative 2.06. Distribution, TCDF, negative 2.06. Degrees of freedom we said was 14, not 14, no, this was different. The degrees of freedom were, oh yeah, 14, correct. Tell me what that is, and multiplied by 2. There's everything. Again, I write everything for your notes, so when you look back, you know exactly what we did. There it is. So I'm getting that to be 0. I'm getting that to be 5.854. 5%. That means fail to reject the null hypothesis. Isn't that the idea? Now let's go do a critical region for you using a t. If you want to use a t distribution, remember this is alpha, and alpha in this case was 5%. So this is 0.05 divided by 2, 0.05 divided by 2. This is the critical region. The rejection region, I kind of mixed that up with that and less problem. The rejection region would be if I go for inverse t distribution and I take 0.05 divided by 2, degrees of freedom we said was 14, paste and tell me what that is, and that turns out to be a negative 2.14 and positive 2.14. And you look at our value, it's 2.06, which is to the left, so you fail to reject H naught. Now we come to this R, this new business. I need to figure out, the R is right there, that is 0.48, no, 0.48 and negative 0.48. Take that back. I mixed them up. Here. I mixed them up. I'm sorry. That's the R. I want to figure out the region. Remember, if it falls in here, that means there's no correlation. Here they are correlated. And here they are correlated. Here it's positive, and here is strong negative correlation. To find the value, I'm going to go in and copy out of that sheet. I want n equal 14, right there, and alpha equal 5, n equals 16, alpha equal 5, so it's right there. It's that one right there, 0.497. Let me copy that down, and just where am I going to squish that? Here. I'm going to shift this down just a bit so I could. Okay, and now I'm going to say, let's cut off n equals 16, and let's take both values in. That's not a problem. We will adjust them in a minute. Shrink that a bit. Move it out of sync. There it is. So, since alpha is 0.05, we know that this is 0.497, negative, and 0.497. Now we look at R and we say, look, R is 0.48. Isn't 0.48 to the left of that? Right? That means there's no correlation between them. No correlation between them, that means rho equals 0. So they all agree. So fail to reject the null hypothesis. Now what? Now the conclusion. There is not, based on those themes, there is not enough sample evidence to conclude or to support, however you want to write it, to support a significant linear correlation between payroll and percentage of games won. And that's pretty much it.